Hi again. Okay, we're going to continue our discussion about ratios. And so you might come across a time when you need to check and see if two different ratios are equal or not equal, okay? So if I tell you that there's something in this world I have 6 of and that's compared to 12, so I have a ratio of 6 to 12 on something, and I have a ratio of 1 to 2 on another thing, and I want to see if that's an equal ratio. The way that I'm going to do that, to check and see if they are equal ratios, is I'm going to multiply across. So I'm going to multiply that 12 times 1, and I'm going to see if that total is the same as if I multiplied this way, with 6 times 2. So what is 12 times 1? Well, anything times 1 is itself, right? So I know that's 12. 6 times 2, that's also 12. So once I've done that, then I find that these two ratios are equal. And we could have looked at it as a fraction also, you know. We could have set them, we could have said, well, I got to find a common denominator, right? So that would be 12. That would be 12, that would be times 6, that would be 6. But sometimes this isn't always the best way to do things, because you might have something that doesn't, you know, it's got a super huge common denominator. And so a quick way to see if two different ratios are equivalent is to simply make them into fractions and multiply straight across. Let's look at a different example here. I have a ratio of 2 to 4, and I want to see if it's equal to a ratio of 4 to 8. So again, I'm going to multiply the across, multiply the numbers that are diagonal from each other. And then here I'm going to see, okay, so 4 times 4, that's 16, and 8 times 2, that's 16 also. So these two would be equal. Yay! Let's look at a third example here. 8/9 compared to a ratio of 9 to 8, right? So again, I'm multiplying diagonally to see if I end up with the same number. So 9 times 9, 81. 8 times 8 is 64. So down here I would say these are not equal. Those two ratios are not equal because when I cross multiply and go and multiply them with the one that's, you know, diagonally across, I end up with two different amounts. So that it is not an equal ratio. They're not equivalent. Let's look at an example. All of those three examples I could have done the fraction way, but let's look at an example where it might not be feasible to do, to use a fraction. What if I had a ratio of 2 to 7 and a ratio of 1.5 to 4? How weird is that? We've got this written as a fraction and all of a sudden we have a decimal point up top. That is just bizarre, right? But if we use this method and multiply straight across, then we can see whether we're going to end up with the same number. And it doesn't matter that there's this funky decimal in the numerator of my fraction. All we're simply doing is comparing these two ratios. I'm going to start over here because this is math I can do in my head. I'm going to multiply that 4 times that 2, and I get 8, right? Here, I'm going to multiply 7 by 1.5, but I don't know 1.5s very well, so I got to come down here and do some math. And I've got 1 behind the decimal point, and do some math to find out what my answer is. So 10.5. So here I have 10.5, here I have 8. Are those equal? They are not. Hopefully you can see that. So I will say that these two ratios are not equal.